GISP Unofficial Study Guide, Section 7, Database Design and Management. Section 701, Understanding of Relationships Among Database Objects. Schema. Schema is the structure or design of the database or database object. Schema can include tables, views, indexes, stored procedures, and triggers. Schema defines the tables, the fields in each table, and the relationships between fields. A schema will include information on which fields have domains and what those domains are. A data dictionary. A data dictionary is a catalog or table containing information about the datasets stored in a database. Domain. A domain is the range of values for a particular metadata element. Attribute domain. Attribute domain enforces data integrity and identifies which values are allowed in a field in a feature class. A coded value domain. A coded value domain is an attribute domain that identifies a set of permissible values for an attribute in a geodatabase. It has a code and its equivalent value. Range domain. A range domain is a type of attribute domain that identifies the range of permissible values for a numeric attribute. Spatial domain. Spatial domain is the allowable range for x and y coordinates and for m or z values. Tables. Tables are a collection of related data held in a structured format within a database. Tables contain fields and rows. Views. Views are a result of a set of queries on the data. Users can query the data to produce a view. A virtual table can be computed dynamically from data when the view is accessed. Sequences. Sequences are ordered collections of objects in which repetitions are allowed. The number of elements is the length of the sequence. Synonyms. Synonyms are an alias or alternate name for a table, view, sequence, or other object. Indexes. Indexes are a data structure that improves the speed of data retrieval operations in a database table. Indexes cause more storage space and additional writes. They quickly locate data in the database. Indexes can be on multiple columns. Clusters can be either multiple servers share one storage. This is typically used to handle user loading balancing. Databases distributed to different servers using replication. This is typically used if you have multiple users utilizing the same data in different physical locations. There is a master database that the replica databases sync between. Database links. Database links are data stored in different databases but accessible by the database currently being accessed. A snapshot. A snapshot is the state of a system at a particular point in time. A snapshot can be used as a backup. A procedure. A procedure is a subroutine available to applications that access a relational database system. Procedures are used for data validation and access control mechanisms. A trigger. A trigger is procedural code automatically executed in response to certain events on a particular table or view in a database. Functions. Functions are subroutines. Functions are sequences of program instructions that perform a specific task. Package. A package is built from a source with one of the available package management systems. Non-schema objects include users, roles, contexts, and directory objects. Database schema. The database schema is the structure of a database described in a formal language supported typically by a relational database management system. The term schema refers to the organization of data as a blueprint of how the database is constructed. In the case of relational databases, the database is divided into database tables. The formal definition of a database schema is a set of formulas or sentences called integrity constraints imposed on a database. These integrity constraints ensure compatibility between parts of the schema. All constraints are expressible in the same language. A database can be considered a structure in realization of the database language. The states of a created conceptual schema are transformed into an explicit mapping, the database schema. A relational database. A relational database is a database based on the relational model of data as proposed by E.F. Codd in 1970. E.F. Codd termed the relational database a relational model of data for large shared databanks. A relational model organizes data into one or more tables, or relations, of columns and rows, with a unique key identifying each row. Rows are also called records or tuples. Columns are called attributes. Generally, each table or relation represents one entity type. The rows represent instances of that type of entity. Each row in a table has its own unique key. Rows in a table can be linked to rows in other tables by adding a column for the unique key of the linked row. Such columns are known as foreign keys. Most physical implementations have a unique primary key for each row in a table. All data are stored and accessed via relations. Relations that store data are called base relations, and implementations are called tables. And implementation are called views or queries. Domain. A domain describes the set of possible values for a given attribute. Constraints. Constraints are often used to make it possible to further restrict the domain of an attribute. For instance, a constraint can restrict a given integer attribute to values between 1 and 10. Constraints provide one method of implementing business rules in the database and support subsequent data use within the application layer. SQL implements constraint functionality in the form of check constraints. Constraints restrict the data that can be stored in relations. A primary key. Every relation or table has a primary key. A primary key uniquely specifies a tuple within a table. Foreign key. Foreign key refers to a field in a relational table that matches the primary key column of another table. It relates the two keys. Stored procedures. A stored procedure is an executable code that is associated with and generally stored in a database. Stored procedures usually collect and customize common operations like inserting a tuple into a relation, gathering statistical information about usage patterns, or encapsulating complex business logic and calculations. Frequently, they are used as an application programming interface, or API, for security or simplicity. Index. An index is one way of providing quicker access to data. Indices can be created on any combination of attributes in a relation. Queries that filter using those attributes can find matching tuples directly using the index, without having to check each tuple in turn. This is analogous to using the index of a book to go directly to the page on which the information you are looking for is found, so that you do not have to read the entire book to find what you are looking for. Relational operations, or relational algebra. Queries made against the relational database and the derived revlars in the database are expressed in a relational calculus or relational algebra. The union operator. The union operator combines the tuples of two relations and removes all duplicate tuples from the result. The relational union operator is equivalent to the SQL union operator. Intersection. The intersection operator produces the set of tuples that two relations share in common. Intersection is implemented in SQL in the form of the intersect operator. The set difference operator. The set difference operator acts on two relations and produces the set of tuples from the first relation that do not exist in the second relation. Difference is implemented in SQL in the form of the except or minus operator. The Cartesian product. The Cartesian product of two relations is a join that is not restricted by any criteria, resulting in every tuple of the first relation being matched with every tuple of the second relation. The Cartesian product is implemented in SQL as the cross-join operator. The selection, restriction, or operation retrieves tuples from a relation, limiting the results to only those that meet a specific criteria. The SQL equivalent of selection is the select query statement with a where clause. The project operation extracts only the specified attributes from a tuple or set of tuples. The join operation. The join operation, defined for relational databases, is often referred to as a natural join. In this type of join, two relations are connected by their common attributes. MySQL's approximation of a natural join is the inner join operator. In SQL, an inner join prevents a Cartesian product from occurring when there are two tables in a query. Relational division. The relational division operation is a slightly more complex operation and essentially involves using the tuples of one relation, the dividend, to partition a second relation, the divisor. The relational division operator is effectively the opposite of the Cartesian product operator. The most popular systems for database management engines are Oracle, MySQL, Microsoft SQL Server, PostgreSQL, which is free, IBM DB2, Microsoft Access, SQLite, which is free, MariaDB, which is free, Snowflake, Microsoft Azure SQL Database, Apache Hive, which is free, and Teradata Vantage. Section 702, Understanding of Database Design. Database design is the process of producing a detailed data model of a database. The design process includes conceptual schema, logical data model, and physical database design. Conceptual schema, stage of the process. In this stage, you determine where relationships and dependency is within the data. The logical data model. The logical data model process arranges data in a logical structure that can be mapped into the storage objects supported by the database management system. Physical database design. Physical database design includes the physical configuration of the database on the storage media, the detailed specification of data elements, data types, indexing options, and other parameters residing in the database management system data directory. Modules, hardware, and software. The three stages of database design are conceptual schema, logical data model, and physical database design. Field types. The proper field type will secure data and make databases more efficient. A short integer can store numbers between negative 32,768 and 32,768. A long integer can store integers between negative 2 billion and positive 2 billion. A float is a single precision floating point numbers. A double is a double precision floating point number. Text could be a coded value. Dates are a calendar date and sometimes a time. Blobs are data stored as a long sequence of binary numbers. ArcGIS stores annotation and dimensions as blobs. Object identifiers are unique IDs and FIDs. Global identifiers are global ID and GUID. Global identifiers are data types stored in registry-style strings consisting of 36 characters enclosed in curly brackets. A raster field type can be stored within a geodatabase, and geometry field types can include point, line, polygon, multipoint, and multi-patch data types. An overview of geodatabase design. Geodatabase design is based on a common set of fundamental GIS design steps. GIS design involves organizing geographic information into a series of data themes, or layers that can be integrated using geographic location. Each GIS database design begins with deciding what geographic representations will be used for each dataset. Individual geographic entities can be represented as feature classes, sets of points, lines, and polygons, imagery and rasters, continuous surfaces that can be represented using features such as contours, or rasters such as digital elevation models, or triangulated irregular networks using terrain datasets, and attribute tables for descriptive data. Each GIS will contain multiple themes for common geographic data. The collection of themes acts as layers in a stack. Each theme can be managed as an information set independent of the other themes. Each has its own representations. Section 703, Knowledge of Database Management and Administration. Basic tasks: backup and recover databases. Test backup and recovery plan. Ensure backups are done on schedule. Database security. Prevent hackers, security models, tasks authentication and authorization. Auditing. Make sure the right people have the right access. Storage and capacity planning. Disk storage is needed and monitor disk space and watch growth trends. Performance monitoring and tuning. Identify bottlenecks. Tuning means using indexing, queries on the speed of return, right monitoring tools, capacity of server hardware. Troubleshooting. Quickly ascertain problem and correct it. Other. High availability and ETL functions. Data extraction, transformation, and loading. Archiving. Captures, manages, and analyzes data changes. That's most often done with the geodatabases. Retrieval is extracting data from a backup due to data loss or data corruption. The Geodatabase Administrator in SQL Server. In Microsoft SQL Server, the Geodatabase Administrator can be either a user named SDE or a login that is mapped to the DBO user in the database that contains the geodatabase. The Geodatabase Administrator is responsible for the administration of the following: the geodatabase system tables, triggers, views, and procedures. The default geodatabase version. GIS data administration. How GIS data is managed has changed dramatically over the past 10 years. The big focus in the 1990s was to move GIS data resources together in an enterprise geodatabase, where users could better manage and share enterprise data resources. Data management today includes multiple publication formats to improve display performance and capture change over time. A variety of data management and distribution strategies are available today to improve data access and dissemination through the rapidly expanding GIS user community. The volume of data you must sort through each day is growing exponentially. How you manage, organize, and control these data resources is critical to your success. There are two kinds of data: useful data and useless data. Useful data is what you use to create business information products and enable informed business decisions. Useless data is what you do not use. GIS Feature Data Production Database. A production data source is an enterprise geodatabase used to organize and manage your geospatial feature data resources. A GIS Feature Data Publication Database. A publication geodatabase is an enterprise or file geodatabase used to optimize distribution of finalized geospatial data resources. GIS Feature Data Map Cache. A feature data map cache is a collection of preprocessed tile map images stored at multiple scales for rapid dissemination. ArcGIS Data Stores. An Esri-managed data repository that stores spatial content that has been shared to the portal. GIS Feature Data Archiving. Geodatabase archiving. It includes functionality to record and access changes made to all or a subset of data in a versioned geodatabase. The release of ArcGIS technology introduced the Enterprise Geodatabase, which provides a way to manage long transaction edit sessions with a single database instance. Enterprise supports long transactions using versions, which are different views of the database. A geodatabase can support thousands of concurrent versions of the data within a single database instance. The default version represents the real world, and other named versions are proposed changes and database updates in work. What is versioning? Geodatabase versioning allows multiple users to edit the same data in an enterprise geodatabase without applying locks or duplicating data. Users access an enterprise geodatabase through a version. When you connect to a multi-user geodatabase, you specify the version to which you will connect. There are two types of versioning available: traditional versioning and branch versioning. Traditional versioning provides the flexibility to work within versions for long transactions when accessed directly from the enterprise geodatabase, and a simplified editing experience when using feature services to accommodate shorter transactions. Branch versioning facilitates the WebGIS model by allowing multi-user editing scenarios and long transactions via feature services. Section 704, Knowledge of Data Security. A data owner. A data owner is a user who creates tables, feature classes, and who owns those datasets. User access. Database must verify the user accounts that connect to it. An administrator has full control of the database, can read, create, update, delete features, and can create and delete feature classes and tables. An editor can read, update, create, and delete features. A reader can only view data. A creator can create additional feature classes, tables, as well as read, update, create, and delete features. Authentication. Authentication database checks the list of users to make sure a user is allowed to make a connection. Authentication can take place on the operating system or on the database. Groups. You can grant groups of users based on their common functions. Public role. The right granted to anyone connected to a database. What does a database administrator do all day? Data integrity is a database administrator's #1 responsibility. Although data integrity is the #1 job, the database administrator has many other jobs as well. Database administrator tasks include installation, configuration, upgrade, and migration, backup and recovery, database security, storage and capacity planning, performance monitoring and tuning, and troubleshooting. In addition to the basic responsibilities, some database administrators need special skills because of how the database is being used. High availability. With the advent of the internet, many databases that could have been available only during the day are now required to be available 24 hours a day. Very large databases. As datasets become larger and larger and more data is saved, the data needs to be structured in ways that it can be easily accessed. Data extraction, transformation, and loading, ETL. In data warehouse environments, a key task is efficiently loading the data warehouse with large volumes of data extracted from multiple existing production systems.